Question 1. A solutions architect is designing an application that requires data to persist on the root volume when an EC2 instance is temporarily shut down for maintenance, without being billed for compute time during the shutdown period. Which EC2 instance state meets these requirements? Option A, pending. Option B, running. Option C, stopped. Option D, shutting down. The correct answer is stopped. Here's the explanation. When an EBS-backed EC2 instance is in the stopped state, its root volume data and private IP persist. You are billed for EBS storage, but not for compute time, which aligns with the requirements. Terminated would result in data loss, and running would incur compute billing. Question 2. An application running on an EC2 instance needs to retrieve its own instance ID and the IAM role credentials assigned to it. Which method should the application use to securely obtain this information? Option A, access AWS Secrets Manager from outside the instance. Option B, query the EC2 Instance Metadata Service, IMDS, endpoint from within the instance. Option C, check environment variables configured by the AMI. Option D, connect to the EC2 API directly using static credentials stored on the instance. The correct answer is query the EC2 Instance Metadata Service, IMDS, endpoint from within the instance. Here's the explanation. The Instance Metadata Service, IMDS, is specifically designed for an EC2 instance to retrieve information about itself, including its instance ID, instance type, and temporary IAM role credentials via a special link local IP address, 169.254.169.254. Options A and D are less secure or not designed for this specific purpose, and C is not a standard or reliable method for these dynamic details. Question 3. A developer uses EC2 user data to install necessary software and configure a web server on a new instance. After the initial launch and configuration, the developer stops the instance and later starts it again. What will happen regarding the user data execution? Option A, the user data script will execute again on the second boot. Option B, the user data script will only execute if the instance type is changed. Option C, the user data script will not execute again, as it only runs on the first boot. Option D, the user data script will execute partially, only applying new changes. The correct answer is, quote, the user data script will not execute again, as it only runs on the first boot. Here's the explanation. User data is designed to be executed only on the first boot of an instance. If an instance is stopped and then started again, the user data script will not re-execute. For ongoing configuration or changes after the first boot, tools like AWS Systems Manager should be used. Question 4. Which statement accurately describes the billing model for AWS Lambda? Option A, you pay for the time your code is running, rounded up to the nearest second, plus a charge per request. Option B, you pay for the provisioned server capacity, even when your code is not running, plus a charge per request. Option C, you pay only for the compute time consumed, measured in milliseconds, and the number of requests, with no charge when code is idle. Option D, you pay a fixed monthly fee for each function, regardless of execution time or requests. The correct answer is, quote, you pay only for the compute time consumed, measured in milliseconds, and the number of requests, with no charge when code is idle. Here's the explanation. AWS Lambda's pay-per-execution billing means you are charged based on the number of requests and the duration your code executes, measured in milliseconds. There is no charge when your code is not running, making it cost-effective. Question 5. A developer is building a latency-sensitive application using AWS Lambda and is concerned about cold starts. Which feature should they implement to mitigate this issue? Option A, reserved concurrency. Option B, dead letter queues, DLQs. Option C, provisioned concurrency. Option D, VPC connectivity. The correct answer is provisioned concurrency. Here's the explanation. Provisioned concurrency pre-initializes a requested number of execution environments, significantly reducing cold starts for latency-sensitive applications. Reserved concurrency prevents throttling but doesn't solve cold starts directly. Question 6. A Lambda function needs to access a private Amazon RDS database within a VPC. What configuration is required for the Lambda function to connect to this database? Option A. The Lambda function requires an IAM role with RDS access permissions, but no VPC configuration is needed as RDS is a managed service. Option B. The Lambda function must be configured with specific subnets and security groups within the VPC where the RDS database resides. Option C. The Lambda function needs to use an API gateway endpoint to proxy requests to the RDS database. Option D. The Lambda function must be deployed as a container image with the database driver embedded, eliminating the need for VPC configuration. The correct answer is the Lambda function must be configured with specific subnets and security groups within the VPC where the RDS database resides. Quote, here's the explanation. A Lambda function needs to be configured within a VPC by specifying subnets and security groups only if it needs to access private resources within that VPC, such as an RDS database. This allows it to create elastic network interfaces, ENICE, within those subnets. Question 7. A developer is building an AWS Lambda function to process large video files. They are concerned about the function's execution duration and the size of the temporary files it generates. Which two Lambda limits are most relevant to these concerns? Option A. Memory allocation and environment variables size. Option B. Timeout and ephemeral storage (TMP) size. Option C. Deployment package size and synchronous payload size. Option D. Concurrency limit and file descriptors limit. The correct answer is timeout and ephemeral storage (TMP) size. Here's the explanation. The timeout limit, up to 15 minutes, directly controls the maximum execution duration. The ephemeral storage (TMP) limit, up to 10 gigabytes, dictates the maximum size of temporary files a function can generate and store during its execution. Question 8. A Lambda function is experiencing performance issues with CPU-intensive tasks, even though its memory usage is well within the allocated limit. What is a common way to improve the CPU performance of a Lambda function? Option A. Increase the ephemeral storage (TMP) limit. Option B. Increase the function's allocated memory. Option C. Decrease the deployment package size. Option D. Configure a dead letter queue, DLQ. The correct answer is, quote, increase the function's allocated memory. Here's the explanation. In AWS Lambda, increasing the function's memory allocation not only provides more RAM, but also proportionally increases the available CPU power and network bandwidth. This is a primary lever for performance tuning compute-intensive tasks. Question 9. A critical, latency-sensitive serverless application uses AWS Lambda for its backend API. Users occasionally report high latency, especially after periods of inactivity. What is the most effective Lambda feature to mitigate these? Cold start? Delays? Option A. Increasing the function's memory allocation. Option B. Implementing a dead letter queue, DLQ. Option C. Utilizing provisioned concurrency. Option D. Reducing the environment variable's size. The correct answer is utilizing provisioned concurrency. Here's the explanation. Provisioned concurrency pre-initializes a specified number of execution environments, keeping them warm and ready to respond instantly. This is the primary solution for mitigating cold start latency in latency-sensitive applications. Thanks for watching. Please subscribe to my channel.